Hi, good evening. So, we'll just have a small 2 3 minutes catch up on what is actually container. So, many of you would be hearing a lot about container these days. Let me give you a short snippet as to what actually container are and how you can relate it to earlier compute instances. Today, whenever we talk about compute, nobody is actually talking about virtual machine or servers. They are all talking about either containerization or serverless. Just to help you understand what actually is a container or those serverless instances, uh, what you would be seeing is three different setup. One is physical deployment, the other being virtualized setup, and lastly, it's a containerized setup. So, what is the difference? Now, if I look at the physical deployment, that used to be a very predominant setup before even the virtualization became mainstream. So, every server used to have its own operating system with no virtualization, and each server used to have just one application running on it. Now, this was a very simple setup, but then it was very complex because the number of servers, the inventory, they keep growing, and then of course it's an expensive one to maintain. Now, again, the customers usually have a lot of servers, a lot of inventory gathered to them, but then at the end of the day, as the CPU cycles and number of cores in physical servers started to grow, the consumption of those boxes was very less, that a physical or that one application cannot use. So to counter that came the virtualization, uh, and I believe VMware played a very big role in that. But then there was one, so the virtualization of x86 boxes or virtualization of servers solved one problem, that is it at least allow you greater utilization of your physical servers. But then inside those physical servers you create a virtual machine. It has its own operating system, and you install all the standard application or specialized application that you want to use inside those VMs. Now the thing is, although it's a virtual machine, but at the end of the day, it is just like a normal server. It has only been virtualized. So whatever you used to run on that old physical box, you are just running everything as it is on your virtual machine. So the now whenever you install an application, you do need to have your application environment with you. So whenever this process keeps on repeating. Now earlier we used to have number of physical boxes. Now it is being replaced by number of virtual machines. But then again, this was also not the best way to actually look at things. Now there are a lot of issues we can talk about in terms of why virtual machines are also not good and how container are helping it. But then this video is just to understand the physical difference between them, how they look like or what does architecture look like. So why do we need container then? So one main difference between virtualized setup and a containerized setup is the virtualization gives me abstraction of my physical resources as in server at a compute level. It allows me abstraction at that level, whereas containerization allows me abstraction or virtualization of my OS, the operating system. Now how is a virtualized setup and a containerized setup different? So if you could see that virtual machine, again it's nothing but similar to physical setup, but in a containerized setup we have we can have a virtual machine there as well, but we see that instead my containers are running within the virtual machine. So it is similar to what you can say, it is playing the role of a normal server there. Now containers, they are a very small compute instance which consume memories in MBs, 2 GBs they can, but then they are a kind of runtime environment which runs or which consume very less compute instance. Now, what a container or what a container engine does is, it, instead of doing abstraction at a physical server level, it does the abstraction of the host, at operating system level. So, for example, my application A, which is running on a container, uh, it does not have any. So that particular container does not have any operating system installed in that container. None of my container will have any operating system installed on it. Container has nothing but your application code and the necessary runtime environment libraries which it requires to run that particular application. That's it. It's a very, very lightweight unit, and hence it's portable. Now, one of the main benefit when you get to this kind of architecture, or when you deploy this kind of setup, is it is seamless. So if I deploy this code in my test and development environment, I simply push these containers there, they'll run it. And when I deploy these environment to my production setup, these containers will run as is. That means I have a uniform experience in all my environment, whether I run it in test, dev, or production. It does not happen that my production is not at the same patch level, or is missing some updates there. It will not happen here. It will provide me a uniform experience, and there's again the portability and the lightweight is very, very handy. Thank you.